Now we are going to create 3 data sets to record statistics of population. Then we found analysis class, drag dataset to the main canvas. Name the dataset as age of death in order to record the age of death. Keep up to 200 latest samples. I think because 200 samples can store most of the cases when during 1 year people would die. If less than 200, there might be an error called out of stock. So let's Ctrl+C, Ctrl+V to get another dataset with the same settings. Let's name it as number of MI. Then Ctrl+C, Ctrl+V, and third one would be number of strokes in order to record the number of strokes. We're going to draw a dialog group in order to show the information of the patient we clicked at. In the presentation class, we found the rounded rectangular. Drag here. Change the line color as light gray. And then draw a triangular here, draw a triangle shape here. Double-click polyline, click once, click, double-click to end. Fill color as white, line color as light gray. Meanwhile, we want to change the height of this rounded rectangular according to the information we are going to show, because sometimes one patient has only 1 stroke history, but other patients might have more than 1, so we need to change the height. Yes. We want to change the height of this patient according to the information it has. Okay. Here, height. Here we are going to use this function, 12 pounds times patient's stroke history size. This means the patient we clicked on. This means the stroke history this patient has. If he has 2 history, and then it will be 12 pounds times 2. Similarly, we are going to change the height according to the MI history as well. At last, if this patient is dead, we will give 12 pounds for the information when this person is dead. If this person is alive, and then he would have no information of death, so we won't leave any space for his death information. At At last we leave 50 pounds in order to show the content in a better way. So let's paste the function here. Then it's done. Then we need to add text in this information group. Let's set its original text as info. If we click nowhere, it will show info, the original color as blue. And then if we click at somebody and we want to show the information about this patient, so we have to change this patient's information using this function. First, we want to show the patient number. The number would be returned by inspected patient variable. And patients.get patients, inspected patients is the patient we clicked on. That patient's toString function of this patient we defined before will return the information of this patient as we defined before here, the BMI index and stroke MI died age. So let's paste this function to the text. Okay, finally we are going to group these three elements by group. Right click, find group, create a group, then drag here. Now let's check our model by run this model. Yes, so all the elements are here. If you didn't see the presentation of patient agent, you should check the properties of agent patients. There is a show presentation button. You should click it, and then the presentation of this patient would show on the screen. Now we are going to add two events. One event is the annual event used to update death cost, death age, and statistics of population in the main agent. Let's go to the agent palette and find the event. Drag event to patient canvas. Rename the event as annual event. This event is used to update variables like death cost, death age, and statistics in main class. Age of death, number of MI, number of strokes. It will be triggered by the end of 1 year, so the trigger type is timeout, occurs every year, so it's cyclic. Recurrence time 1 year. We're going to define the action of updating data in this action text box. I type the function in this textbook. First of all, we have to judge whether this patient is dead or not. If this patient is already dead, we won't do anything about his variables. If this person is still alive, and then we need to decide whether this person is going to die this year or not in this part. If this person is still alive, we are going to decide whether this person is going to have MI in this part, or whether this person is going to have stroke in this year in this part. So first of all, we have to decide whether this person is going to die this year according to the probability table of death we define in the main agent at current age. We're going to get a probability from this table at current time. And then if this person has MI history, that is, MI history size is larger than 0, we will multiply by 1.1 to larger the probability of dying of this person. Similarly, if this person has a stroke history, and then we'll times 1.9 of this probability. If this person doesn't have MI history or stroke history, we only multiply by 1. That means we keep the same death probability as a normal person. So under this probability distribution, if this person random true is true, that means this person is dead this year, and then we set dead equals to true, death age equals to current time, and life expectancy of this person would be current time. So we will add this number to life expectancy distribution. In the main, age of death would add current age of this person. Number of strokes would add this person's stroke history size, that is how many times this person has the stroke. Similarly, the MI and death cost would be 200, so the cost would add 200 for this person. If this person is still alive, we're going to decide whether this person is going to have a MI this year. So here random true is based on the MI probability table of current time, the probability of getting MI times BMI divided by 20 is an index. This index shows the healthy state of this person. MI history at the current time, that is the age of this person. If this person has MI, because according to random true, if it is true, and then we'll go to this step. So in this part, this person already has an MI history, and then we're going to add the current age of this person to MI history. The length of MI history array would be added 1. Cost add 1,000. Because insurance company, they would pay for this person's curement. Then if this MI history array size equals to 1, that means this is the first time this person has MI. So the first MI age distribution would add current age of this person. That would be the statistics of the population. If this similarly, according to the probability table and healthy state of this person, we'll decide whether this person would have a stroke or not. If it is true this person has a stroke, and then we need to update the stroke history, adding this person's current age, and the cost would add 2,000. It means to cure a stroke is more expensive than to cure an MI. And we are going to update the first stroke age distribution. If this person has the stroke for the first time, the stroke size equals to 1. At the end, if this person has MI history or this person has stroke history, the cost would add to 100. Because maybe he might go to the hospital for treatment or to get regular medicine. Now we are going to place all those functions into action. Then this annual event is done. Let's build it. Okay. No error shows. Finally, we're going to build the event to update variables in the main. Drag the event from the agent palette to the main canvas, and then rename the event as update numbers triggered by timeout. It's cyclic event because it will be used to update the variables every year, and recurrence time is 1 year. Now we're going to define the action of updating those variables. So here is the function we're going to type. First of all, we need to set number of no event and no event equals to 0, and similarly other variables equals to 0 at first. And then we'll use a for loop to walk through 100 patients to check how many patients are dead, how many patients have MI and stroke, or MI or stroke. So P represents every patient in this loop. If this patient's dead state is true, that means this person is dead. Number of dead would add 1. Plus means add 1. Similarly, if this person has MI, that is MI history size is larger than 0, and this person's stroke history size is also larger than 0, that and MI stroke would add 1 as well. It is the same thing here for the MI history and number of stroke. If nothing happens before, and then number of no event would add 1. The total cost would add this person's cost. So let's use this, paste here. Try to do the model. Let's run this model. Accelerate the speed. Those points are dead patient. We can see the change of this population. If we click, at one point we can see this patient's index, BMI, and information of stroke, death. Okay, I think it reaches to 100 years. This is the result of our model now. Okay, thank you.